Welcome back. Here's another so-called lecture. And basically, if you followed last time, I'll do the same thing, pretty much show the slides and just provide a voiceover. I'm doing this for a number of reasons. One, I think it's the smallest file sizes I can deliver. I am limited on my end by our connection, and it takes an awful long time to upload things to YouTube just right now. I'm not sure if that's the case for everyone else, but I'm trying to make these small, and so this is one way to do it. Before we get going, I just want to mention that these slides have been adapted from Dr. Ahmed Al-Rawi's slides, which are amazing and awesome, and I think they have a really cool look, so I'm using those, and he's good with that, and so I just want to credit him before we move on. So what we're going to cover in this lecture is sampling. It's a really important part of this process and something we should be really thinking about whenever you do a survey or look at data in general. What actually are we looking at? How did we get that data? What were the sampling considerations at all times through the process? So what you're looking at right now, random shapes and words, no. Basically the idea of sampling is you got a large population. That's the big circle there. Sampling frame, and we'll talk about all these terms as we move through this, is basically a list that you use to select from. You have some kind of sampling process, and we'll cover a number of those, which leads to a sample. Pretty basic when you look at diagrams like this, and it is actually very basic, so don't worry about it. I want to put your mind at ease in assignment 3. Really, we're going to spell it out for you in these videos. We want this to be doable for you, and we want it to be an important part of your learning process, not only in this course, but in your future trajectory, basically. Looking at data, very important. And so here's a blurb from the assignment 3 brief, right? I won't read it out to you because that doesn't make sense, but check it out. Now, I just want to be really clear here. When we're looking at assignment 3, I've gone through and checked out successful assignment 3s, like assignment 3s that have gotten good marks in the past. And I found a range of word count anywhere from 1,500 on the low end to 2,500 words on the high end. So, you know, really you're aiming for something like the mean is about 2,000 words, but it depends on how you write and things like that. What you will find as you start going through the assignment description and plugging in direct answers to the questions and the prompts that are given to you in that description, you'll chew up those words really quickly. Like it just happens. Just putting in very basic sentences like, you know, in this case, the independent variable is blah, 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 and the mean is, and the mode, and all that kind of stuff that we're asking you to do in the assignment brief, it basically writes itself. I really want to be clear about that. It's just use the document as a template. There was a template, but I packed it all together into one document to simplify things. Everything's all in one spot now in one document. And you'll notice that there's this little bit on sampling. So you can expect that if there's like 6 sections, you know, something like a sixth of the overall word count could be put into this section. We're not looking for crazy applications here. We want to just basically cover off the idea of sampling. And we want also to really make the point that we haven't followed certain kinds of procedures that are actually quite important in the sampling process. And we just want to be really clear about that. But we also want to give you an opportunity to be critical. And what I'll be doing in this lecture is just giving you the parts and pieces you need to do that. Very basic stuff. Our expectations in this situation will take into account the stress that you are all going through in terms of marking and expectations all the way through. So I just want to, all of us on the team, just want to guide you through this process, and don't worry about it. It's going to be fine. Honestly, when you start doing the assignment and just following it step by step, it really does in a lot of ways just kind of write itself. Okay, so why sample? Generally, you are selecting observations or members from a population. More importantly, though, really simply put, it saves time effort, and money. Those are important things, always, and especially right now. So that's why we do it. There's two major types of sampling. There's non-probability sampling, and there's probability sampling. And when I say that we want to guide you through this process, I mean, basically, we're going to be pretty straightforward in telling you about what we're looking for. Educationally, I don't like to do that. Generally, we like to leave some room for people to interpret and all that. But, this is, again, acknowledging that this is a stressful situation for everyone. And so I'll be pretty straightforward as I go through these slides about the expectations for that paragraph or that part in assignment 3. We did non-probability sampling, right? Basically, reliance on available subjects. You guys are in a class that you've taken. Let's be honest, you have to take it as part of this process. It's mandatory. So definitely this is a non-probability sampling situation, right? At no point did we get out some, 1,000-sided die and roll it or use any other kind of methods to get probability sampling. So we didn't do that. I just want to quickly go through some other types of non-probability sampling and then look at probability sampling, which is the accepted standard for types of, for surveys and things like that. Although things are changing a lot because of online information and analytics and things like that. But for now, we'll go through this. So non-probability sampling, very simply, the sampling elements are selected using something other than a mathematically random process. Okay, so don't take it wrong. In this case, you're the sampling elements in a sense. How did we get to select you to take the survey? Well, we didn't really. We just gave the survey to a class where it's mandatory. Okay, that's what we did. So that's reliance on available subjects, right? So use of all available subjects at a particular time and place. Hey, it's convenient, inexpensive, I guess, depending on how you look at it. And useful for pre-testing questionnaires or other social measurements. I think that's kind of the gist or the spirit of this exercise in this class. The data that we get, we can't publish for ethical reasons, but also because there'd be huge questions about it in terms of how we got the sampling strategy together. And what it really means, that bottom sentence, super important, it's not representative of a larger population. Or, if you are trying to make inferences to other populations, you should be extremely careful about it for a number of reasons that we'll cover here. So, look, this is us. University researchers frequently conduct surveys among the students enrolled in large lecture classes. Yes. There's an example here. This is taken from Ahmed's slides and his examples. So participants were recruited, I think this is an actual study, Raynaud and Byers, on sexual thoughts and experiences by way of sign-up sheets, class announcements, and such. Now, this is not just to try to make this content a little more exciting so that you actually watch this video. There's a real reason why Ahmed used this particular example. Okay, stay with me on this one. Is there a problem here? Yeah. So researchers did not provide a meaningful representation of students in Canada or even in their university. And this is a really key issue, that second point. Obviously, because this study is about something that some people consider taboo or whatever, there would be a really big difference in students that are willing to participate in it, potentially, than students who don't participate. So it changes how our sample is constructed based on that fact alone, right? So certain students that are more comfortable with issues around sexuality would be more likely to participate. And that's a huge issue when you're trying to infer the results and make claims about other populations based on this study. So that fourth point is that did not address the lack of generalizability to the general population, right? And that's the real issue there. So for our study, our survey, could we say that the results we have would be able to be used in consideration of, let's say, students in Canada or people in your age demographic in Canada or the world or whatever? What population could we use or use our data for to make inferences about? just really simply, right now, as a group, the mean of time spent using social media yesterday is 5.5 hours. Well, 5.45 hours is the mean. That's pretty high compared to other times we've done the survey. And so obviously there's some things going on right now where that's an issue. So you could just see there's a lot of ways to look at the way we did the survey, sampling, and also just the general circumstances that have changed things. So they're all things that we need to think about. If we have a number of the mean number of hours that people spend using TikTok, for example, you might look at that and go, okay, again, bunch of issues in there. How can we, how accurate would it be to say that the results from our survey, that the mean was, I think, 39 minutes, could be extended to other populations? Just things to think about. This is a blank slide inserted on purpose. Here we want to focus on mindfulness, and we want to stare into the gradient, off into the void, and we want to have happy thoughts. Are you with me on that? Happy thoughts. Okay, moving on. Judgmental purposive sampling. We're just going to go through these really quickly. I want to keep this video length down as much as possible. Judgmental or purposive sampling is a type of non-probability sampling where you select units to be observed based on your own judgments about it. And so in a lot of cases, it's actually quite a good way to go. There are very specific instances when you'd want to use this. So I don't want to set this up as in any way that something called purposive or judgmental sampling is incorrect or wrong. It's just that you need to think about the times when you'd want to use this. And that's where you kind of go out of your way to create the sample based on your research question and knowledge of the population. So it can save you a lot of time and effort, for sure, this kind of sampling. But the question is, can you generalize the results to other populations? Snowball, this is what a lot of people use, for sure. And it's because it makes sense. You interview someone, for example, and then you ask them if there's anyone that they can think of that might be good to interview. And it kind of goes on like a snowball that's rolling down a hill, and we all know that sort of, we all have that image maybe in our minds. The ball gets bigger really quickly, right? So this is useful in certain kinds of situations, when it's difficult to find people, when you're doing exploratory research. But again, the weakness there is representativeness is problematic. That is a problem because you're picking those people and maybe you have a bias in how you pick them. So here's some examples: sex trade workers, undocumented immigrants, times where people are maybe not as willing to participate in a study as they would in other kinds of studies. So you got to be very careful about this. But it might be that you have no choice really but to do a snowball sample or some kind of purposive sample. So quota sampling, basically you set out the characteristics of what you're looking for in the first place, and then you set up your sample so that the distribution of characteristics assumed to exist in the population being studied is based on your own research parameters and things like that. We don't want to get too much into this because I think it's probably pretty complicated. Not really complicated, but it's just a little bit beyond what we want to get into because we're not actually asking you to do it, right? But we just want to be aware of these types of sampling methods for your own sake because it's so important, right? So begin with a table describing the target population. Here we have an example. This is another example. If you know that 10% of all communication students are female and international, that's, I'd see that as not a good percentage, but whatever. I think it's much higher. Then you select 10 female international students for an overall sample of 100 communication students. Let's not get into this too much. It's just to get an idea that there's different types of sampling and that there's problems with them, just to get a general sense of strategies for sampling. What could go wrong here? Here you go. Difficult to get up to date or accurate information about the quota frame. So you think you might know what you're talking about basically, but do you really? And you might also be exercising some form of bias as you do that. And this is always a consideration over and over again. How did you come up with that sample? And the question of bias is really critical because it can happen in ways that are obvious sometimes, and then in other times, sneaky little ways bias sneaks in, and you've got a different kind of sample, and then suddenly you run into problems where you try and generalize or infer statements or judgments about a population based on your sample. That's really the key issue that's happening there. Another one, just straight up selecting informants here. Someone, that there's someone that is well-versed in the social phenomenon that you wish to study. So you just go find them, basically. It's pretty simple. Sometimes what this really means is that there's a pretty limited range of people you could speak to given the nature of what you're trying to study. So why try to sample? You just get a bunch of data that doesn't mean anything. Just, go out of your way to select research participants or informants that are going to be able to speak to or provide data or evidence for you that is relevant. So typically, religious sects are used. Often I see examples, and I think in the textbook, gangs or motorcycle gangs and things like that are the kinds of examples where you're doing this. We're not recommending that you do any kinds of studies like that in the moment. Probably not a lot of this kind of research going on right now. Actually I guess you could, as long as you're doing it remotely, all that kind of stuff. And problems with it, again, bias. It's always the same issue. Bias comes up over and over again. You limit the number of potential people that you could speak to and roll the dice on bias. I mean, who knows what's going to happen? So you need to really think about that. And just how your status as a researcher would be limited, and a limiting factor in terms of, say, imagine this is an example. I think it's from the text. Motorcycle gang, you're trying to infiltrate them. They don't really want to talk to you. I mean, they're doing stuff that they don't want other people to know about. So your access to them as a group is most likely limited. Probability sampling. Okay, this is like the standard that is often held up for this kind of research and quantitative research in general for a bunch of reasons. So this means that we use some kind of random selection mechanism, and I've got one at the end to show you, and you can try it out if you want. Very interesting. And basically what this means is that it helps in producing representative samples. And this is everything. This is this whole issue, and basically what we're looking for in that paragraph-ish about sampling, right? Is do our results, are they representative of other groups? And it might be that the answer is yes in some cases, for sure. But there's just a bunch of things we need to think about as we try to do that. So, okay, back to this, So here we have the big circle. That's the full population. Imagine that the population was SFU students in general, right? The undergrad population of SFU students. And just to give you an overview, a sampling frame, that's a list that you come up with. And so the sampling frame could be, you go to the registrars and get a list of students. It's very simple. And then the sampling process, you'd use some kind of random process to select a group. You don't have the time or resources to interview, let's say, everybody, or have everyone fill out a survey or something like that. I think there's something like 30,000 students at SFU now. So we don't want to do that. We want to interview, maybe 100 or something like that. We'd have a much smaller sample to work with, purely because of work. That's where the saving time and effort comes into play. So we would use some kind of sampling process, and then we come up with our sample. Okay, very basic stuff. So inference, I've used the word already and talked about it, but the purpose of inference is to draw conclusions about the characteristics of a population based on what is observed in a sample. That's what this is all about. And, so we don't want to get too much into this stuff about random variation and all that, but it's in the slide and the point. I'll leave it at that. It gets a little more complicated, and really you start to get into things like the normal curve and all that, but let's leave it for now. So the realities of sampling, some populations are extremely difficult to determine. Like you can't even, the example that comes up a lot is homeless people, say in Vancouver, how do you actually even determine that? How do you come up with a list of that? It's pretty hard. Some people might have an idea, but there'd be a lot of work even just trying to figure out who holds that status of being homeless. And all these points probably apply to that, right? Difficulties may arise in making contact. Well, yeah, of course. I mean, they're homeless. How do you get a hold of them? They don't have fixed addresses. That's a huge problem. And probability sampling is also, there's strengths and weaknesses of all these approaches. And again, it's not about trying to say that one is right or one is wrong. It's just that we at least understand what we're trying to do, and use the method as the most appropriate. So sometimes probability sampling is easy. You got a really nice frame to work with, sampling frame. And in our case, I think if we were trying to come up with a representative sample of students at SFU, undergrad students, we could do that pretty easily, actually. We could just go to the registrars, if we were allowed to, if we had the ethical clearance, get a list, and then use some kind of probability or random selection method and come up with a small list of people to work with, informants, or if it's an interview, or people taking respondents for a survey, whatever. But in other cases, probability sampling can actually be very time-consuming and expensive, so it really depends. Like, again, comparing students at SFU versus a population of homeless people in Vancouver, you can see that there's a huge difference in the ways that you could do that. And if you try to do a probability sample with homeless people, it would be very difficult, actually. So that's the point that they're making there. So bias, we've talked a bit about this. This is systematic errors. And typically, the finger is pointed at non-probability samples, and that's an issue. I think you could talk that through both ways. And a lot of times there are people that have a sort of more of a quantitative background, and they like to kind of cast doubt on people that do things differently than themselves, let's just say. So there's a bit of that bias here. But the advantages of probability sampling are pretty straightforward. You try to avoid those selection biases, right? It's not about you making judgments about people to interview or whatever, and you try and avoid that. And again, the key thing is that you are hoping that you can use the results of your sample and the data from the sample in a way that reflects the characteristics of the population. So again, our survey said that people use something like 39 minutes of TikTok on an average day. Lots of issues with that too, in terms of how the question was created, and so lots to talk about. But also, it's because it's not a random process. There's a lot of things about our process that introduces bias. And so, would we be able to extend the results out to, say, SFU students in general? I don't know. It's an interesting question. And the wider you try to cast out, maybe the more problems there are. Like, can we expect that would be the number of minutes that people would report using TikTok by people in your demographic in Canada, for example, that kind of thing? How good are those results? Like, not good, but how representative are they of different populations is the question. That's really what this is all about. So a sampling element, it's the unit of which a population is composed and which is selected in a sample, pretty straight up. So a person, group, city, block, blah, blah, blah. Here, in our case, in our course, it was people, obviously, because you guys took the survey, so that's you. Okay, so what you need to do when you're doing random selection, you need the list of cases in a population, and this is called a sampling frame. It's actually a very simple idea. It's the specific list of units making up a population. So if we were to do something in our course where we did random selection, we could do that. We could just say, okay, the sampling frame in that case would be the students in the class, all of you guys, all of your names on a list. And then we could say, rather than try and interview all 141 of you, which would be a lot of work, we could say, hey, let's interview a sample of just say 10. And in order to do that randomly, we just, a very basic point, we need the full list to do the random selection from. Often these are like phone books, outdated, yeah. Whatever, online versions of phone books, I guess. Lists of people, things like that. Very simple. So you've got your sampling frame, and you use the sampling frame to create your sample. So just here's a question, although this is a little bit more geared towards having a final quiz. A potential study, we're trying to think of a sampling frame in a situation where we're looking at measuring the attitudes of SFU's School of Communication undergraduate students, the population, towards the issue of pipeline protests in this example, right? So what would be the sampling frame in this situation? And I'll let you think about that. Epsom sounds like something you pour into a bath to make it more comfortable, like Epsom salts or something. But no, it's an acronym. Equal probability of selection method, Epsom. So very basic. Sounds all fancy. It's just all members of a given population should stand an equal chance of being selected, right? So if we were going to use our class and do a random selection within our class, we would need to make sure that everyone has an equal chance of being selected to participate. And that's a very important part of all of this. So we would use some kind of random process to do that. And again, I'll show you one at the end of all this. And here, representativeness, that quality of a sample of having the same distribution of characteristics as the population from which it was selected. This is where we get into the normal curve and all that. We don't want to get too complicated here. Just the idea of representativeness is an important one. And it all gets back to that same basic idea, the point I'm making over and over again, basically, is that if we want something called a representativeness, we need to really think about using probability sampling so that we can generalize our results to use, if you want to use inferential statistics and things like that, basically make predictions about populations and their characteristics, then you need to really think about representativeness in that sense. So here we have an example, a national household survey, and we have this number of people claiming Aboriginal identity in 2011. And so here the issue is if you select 10,000 Canadians, it is probable that about 430 Canadians in your sample are of Aboriginal origins based on Epsom, the principles of that, right? So that's just basic kind of math stuff. Again, we don't want to get too fancy with the numbers here. It's the ideas that we're talking about. And so probability sampling, again, is a type of sampling. Simple random sampling is a very basic way of doing probability sampling. And that's where the units in the population are assigned numbers. So again, if our class was this, everyone would get a number. And then we put that into some kind of procedure, assuming that everyone has the same chance of being selected. And we would go through our process. So here's an example from the text. We have a bunch of people, little figures up there, males and females, I take it, and numbers are assigned to them. And then there's some kind of process that selects them. Here it's a table, and however they generate that. And then you come out with a list of 10 people that are in the sample, and you can see their numbers there. So systematic sampling, it's actually a pretty straightforward idea. It seems scary because it's got things like KTH, like kith, I think is how you actually pronounce that. So it seems like a big deal. We don't need to worry about it too much. Every kth, is that how you say it? Element in the sampling frame is chosen for inclusion in the sample, right? So you just go through, and instead of rolling a die every time or having your process, you just pick every, say, 10th person or every 20th person on a list. And the idea is, again, it's saving time and effort so that you don't have to go through some kind of random process every time. You just, boom, you have your list, and you say, you know what, we're going to just pick every 10th name on that list. It's easy. But there are some little ways that bias can sneak in. So here, the sampling interval, that's the distance between elements, right? If it's every 5th or 10th or whatever. And then there's the sampling ratio, and that's the proportion of elements in the study population that are actually selected. Some concerns. There's always concerns, and bias again sneaks in. So there are certain kinds of bias that are problematic when you're doing this kind of sampling. So imagine, here's the example. We select a sample of apartments in an apartment building, and they have a numerical order. And so there's just always a risk that that kind of system will bias the results in some kind of way, right? Here, what is it? The danger of sampling interval coinciding with larger, smaller apartments of those facing one corner. That's just an example. This one, it's a very sexist example, and unfortunately, I think this is the way things were listed. That's, that the husband would be put first. So you have this list, it's a hypothetical list. I don't think we see this much anymore, but I don't know. It's just that if you were to select every ninth, for example, item from this, you'd always get males, right? There would be a bias in that. So that's a very clear example of a bias. And so you have to take that into consideration if you're doing this kind of sampling. So in order to keep the time limit of the video down, that's basically just what we want to cover. There's more coverage in the chapter. I suppose at this point, a lot of that information it would just be for your own benefit. That's fine. Again, just to sum up, the information that we're looking for, or the writing that we're looking for in the section on sampling in assignment 3, it's going to be pretty brief. It's just a couple points. It's allowing you to be critical of what we did, and hopefully we've covered that in this lecture, giving you some things to think about as you try to imagine thinking about other populations that our results could be extended to or used to make inferences about, and making the point that we'd be careful about that. For example, we have more female students than male students in the class, so that's going to change things. All those kinds of things are considerations that we just need to be careful about and do due diligence in terms of trying to generalize the results. And the thing you're looking at here is random.org. Pretty cool. It's a little screen grab there. I'll put up the slides themselves as well, just so that you can click on the links and things like that. Very important. And yeah, if you're ever in the position of needing to do something random, I would highly recommend using this site. It's actually pretty cool. I'm going to crank out here and get to random.org and show you how it works basically. So if we want to generate a random number, let's say we're trying to pick people from this class, and I would say 1 to 141, and we want to pick a number. We just go generate, boom, 31. So if we had all your names on a list and numbered, I would just say number 31, Terrence Lamphage. That's not a name. I just made it up. I don't think there's anyone called that. But anyway, that's how you use it. And so really simply, if you had, I don't know, 30,000 people, let's say, to pick from, what's the random? There you go. 19,693. We'd go through a list and pick that person. The interesting thing about it is if you check out this right up here, at some point they're talking about using atmospheric noise, like noise from the universe that randomly fluctuates, and that's how they generate this random process. Super interesting. Okay, so everybody, I just want to put your minds at ease about assignment 3. Don't worry about it. Like I said, we will be giving you lots of stuff to work with, lots more resources coming your way, and we will address things like extensions and all that stuff in different ways. And just trust me and trust us on the team when I say we will be marking your assignments in consideration of all the things that are happening. But the best thing you can do right now is to keep moving forward and don't get bogged down. At some point, this will all be over and we will be moving on. And we don't want this to be a blank spot in your life, basically, or a waste of money or a waste of time or anything like that. So yeah, make use of the resources we're preparing for you. And if you're isolated, well, we all are, and you really need to do something, or you find your frame of mind is just not where you want it to be. I know this might not sound, it'll sound kind of dumb, to be honest, but hey, you never know what would happen if you just started working on your assignment. You might end up feeling much better knowing that you're doing something and moving everything forward. Okay, I'll talk to you soon. Bye, and thank you for watching.